Hi, video 9.7c, more Maclaurins and Taylor polynomials. So this is numbers 1 through 4 in the book. It says match the Taylor polynomial approximation of the function f of x equals e to the negative x squared over 2. That's that black curve right here. And they want you to match that, the Taylor polynomial with the corresponding graph. Okay, this is ridiculously easy. I think you can tell that the gray graph here is a line. I think you can tell that the gray graph here is a parabola. I think you can tell here that it has 2 relative extrema, and here that it has 1, 2, 3. So this will be linear, this will be quadratic, cubic, degree 4. Pretty straightforward. Okay, so let's do some more to find the Maclaurin polynomial of degree n. Let's look at number 16. Remember, Maclaurin's means it's near 0. I'm showing you on your calculator how you would do this, and the only reason I'm showing, not that you'll have your calculator to do this on the AP, but if you wanted to try some of the evens, this is how you would see what the answers would look like. So you go to catalog, under catalog you type in T, and then you'll see Taylor. You enter the function, you have to tell it with respect to variable x, and then you tell it the degree of the polynomial that you want. By not putting a fourth parameter, you're telling the calculator it's Maclaurin's, which is at c equals 0. Maclaurin's is really a Taylor polynomial where c equals 0. And this is what you'll get. And if you did it by hand, that's what you should get as well. If you want it centered at another number other than 0, you'll have to have comma, whatever that number is. They've actually expanded it, and I will tell you that as human beings, we would actually leave it as whatever times x minus 2 plus whatever times x minus 2 squared. The calculator actually will expand it. Okay, so here's the directions. Go to catalog, Taylor. It's expecting your function, your variable, the order, which is the degree of the polynomial, and optional. If you don't put a fourth parameter, as I said, it'll be Maclaurin's. Okay, so pretty straightforward. So here's another one. Taylor polynomial for sine x with respect to x of degree 5. You could put the 0, and this is Maclaurin's, and this is what you'll get. A couple of things. You'll want to be in exact mode for this. For sine x, Taylor polynomial degree 5 centered at 3, it would be Taylor sine x, comma 5, 3. And what you would get is the following. If in settings the display digits are set to float 3, and you press approximately equals get, it'll actually expand all those x minus 3 squares and x minus 3 to the 5th and add up all the like terms. Okay, so 41 to 44, now they want you to actually use the Taylor polynomial or Maclaurin's polynomial you found to actually try and approximate f of a particular number. So 42 is sending you back to number 13, and number 13, the function was f of x equals x squared e to the negative x. And in that question, go back to number 20. In that question, they had asked for a Maclaurin's degree 4. Okay, so we had already found that, but I'll just go through that. Blah, 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 blah. You're doing it all. You're going from 0 to 4. You take the original function. Now, this is good, but by hand is not fun. This is a product rule followed by another two product rules. Very ugly. I wouldn't give you something that tiresome. Anyways, it is Maclaurin, so C is 0, so we're evaluating all those at 0. Trust me, this is what you'll get. So it turns out, and remember, those are the coefficients of the numerator, right? So you would get 0 for the x to the 0 term, 0 for the x to the 1 term. Then you'd get 2 over 2 factorial x squared, which is here, minus plus negative 6 over 3 factorial, which happens to be 6, times x cubed. And this would be plus 12 over 4 factorial, but 4 factorial is 24, so 12 over 24 is a half times x to the 4th. So, assuming you had the answer to number 20, which is this answer right here, then if you use that polynomial of degree 4 to approximate f of 1/5 is close to 0, it's 0.2, you would replace all those x's by 1/5, and you would get an approximation of 0.0328. If you actually evaluated on your calculator, you wouldn't want to do this by hand because what the heck is the 5th root of e? But if you did it on your calculator and you actually found out what is f of 1/5, you would get 0.03274, and notice how close we are to that.